Good day guys, and welcome to this video. In today's video, we're going to be discussing converting decimal numbers in a given base to another base. The concept of this topic is actually very important because it's going to help us understand how we can carry out different kinds of conversion. In the previous video we did, we converted videos without a decimal point. That is, there was nothing like a decimal point in the ones we've been doing so far. But in this video, we want to look at how we can convert numbers that have a decimal point and a given base to another base. So let's look at some examples. We are asked to convert the following to decimals in base 10. Decimals means numbers that have decimal points, or you can call them bidecimals. Are you getting the concept? So look at these questions. These questions are all binary numbers. We have to convert 0.101. This number is in base 2. We have to convert it to base 10. We have to convert this one to base 2 to base 10. This one to in base 2 to base 10. So all these numbers are bidecimals. That is, they are binary numbers that have a decimal point. Here you get. Now let's have the solution. But before we move on, I want to bring your attention back to something. Now, let's assume you have something in this nature. AB point C. AB point CD. Let's put it in this way. Now, let's assume these are numbers, right? Let's assume A, B, C, D are real numbers. Now, the place value of this AB here actually has a meaning. And this CD here also has a meaning. Now, the A here has a place value. Likewise, the B and the C and D. Right? So the place value of the A here should be tens, and the place value of the B there should be unit. That is, the numbers in front of this point here are whole numbers. Just know that. Numbers at the front of that point, no matter how long they can be, all of them are whole numbers. Then all the numbers at the back of this point, all the numbers here now from CD, no matter how long they can be, they are all decimal numbers. In other words, they are no whole numbers. All the numbers at the back of this point. Are you getting the concept now? So whenever we are treating numbers that are at the front of the point, we treat them as whole numbers, and we treat these numbers as decimal numbers. That's what you need to understand. Now let's move on with the solution. For question 1, we have 0.101 in base 2. We want to convert this number to a digit in base 10. And if you'll be following our videos, we said whenever you are converting a number that is not in base 10 to base 10, we said we multiply each of the digits that make up that number with the base written below it. So these digits now, all the numbers here, I'm going to multiply each of them by this number below it here, which is 2, right? And then I maintain the powers of 10 on top of each. So for the first one here, I'm having 0 multiplied by 2. Are you seeing that? Plus. Now I will take note that after this 0, this is when my points begins. That means all this 1, 0, 1, they are immediately after the point. So I can open a bracket for it. Are you seeing that? Then I have my 1 times 2 plus 0 times 2 plus 1 times 2. I'm securing this in a bracket to just not to mix them up. So this 0 is at the front of the point. This is here. Then all these numbers at the back, I secured it in a big bracket. Are you seeing that? So on top of this one now, this is a whole number. The number at the front here is a whole number. This 0. So on top of the 2, I'm putting powers of 10. So this one is going to be 0. Then on top of these ones at the back here, these are decimal numbers. There's nothing like 0 on top of it. We start with minus 1. So here is going to be minus 1, minus 2, minus 3. So if we work on this one here, this one at the front, we first work with the exponent, the power on top, then we multiply it with the digit here. So 2 raised to power 0 is 1, and 1 times 0 is 0. That means the number at the front here is 0 plus, open your bracket. This is 1 multiplied by if you follow one of the laws of indices, we say whenever we have a number raised to a negative n, right? This is one of the laws of indices. We say the negative there is the inverse of a raised to power n. Are you seeing that? So we have 2 raised to power minus 1. The inverse here, the minus here is 1 over, that is the inverse of 2 raised to power 1. Are you seeing that? If you have 4 raised to power minus 3, the minus there is the inverse of 4 raised to power 3. Are you seeing that now? So I've applied that here. So this one has a negative sign, and that negative sign is the inverse of 2 raised to power 1. Then plus, this one is 0 multiplied by, the negative here is the inverse of 2 raised to power 2, plus 1 multiplied by, the minus here is the inverse of 2 raised to power 3. Let's get rid of this. So if you continue working further, you see that this is going to be 0 plus 1 multiplied was 1 to give us 1 over 2. That means this whole one is 2, plus 0 times everything here is 0. So whenever 0 multiplies anything is 0. That means all this thing here I'm having here is 0. Plus 1 times 1 is 1 over 2 raised to power 3. That's 2 in 3 places, right? That's 8. Are you seeing that now? So I'm having 0 plus. So if we get rid of this 0 now, we're just having 1 over 2 plus 1 over 8, right? So we continue with how we have 0 plus, if you work on the LCM here, that LCM there is 8, right? So we have 8 as the LCM. 2 goes in 8 how many times? That's 4. And 4 times 1 is giving us 4. 8 goes in 8 how many times? That's 1. 1 times 1 is giving us 1. So we have this. So if you continue working further, it implies that we have 0 plus, we have 4 plus 1 is 5 all over 8. And 0 plus 5 over 8 is still 5 over 8. You can decide to leave your answer in a fraction form. This answer is now in base 10. Or you can convert your answer to decimal. And to do that, you just have your 8 root in this way. Alright? So how many 8 can you see in 5? That's 0. 8 times 0 is 0. Subtract, you have 5. Add your point, and that's 0. 8 in 50 there is 6. 8 times 6 is 48. When you subtract, you have 2. Keep adding 0. And 8 there is 2. 2 times 8 is 16. When you subtract, you have 4. Add 0. And that's giving you 5. So when you multiply, you have 40. And when you subtract, you have 0. So it means this is your answer, or you have 0.625 in base 10. Are you getting the concept now? So for question 2, we are going to apply the same principle here. For question 2, we have we have to convert 101.11. 101.11. This number is in base 2. We have to convert this to a number in base 10. So we are going to do the exact same thing we did here. Multiply each of the digits in this number by the old base. So I'm having 1 times 2 plus 0 times 2 plus 1 times 2. That's all for the front, right? Then plus, open a big bracket now because I'm having 2 numbers after the points. So I want to separate them. So I have 1 times 2 plus 1 times 2. So I have this. So these numbers in this big bracket are numbers after the decimal point, right? So for the numbers at the front of the point, these 3 numbers here, on top of the 2, I'm adding powers of 10, starting with 0, 1, and 2. Then for numbers at the back of the point, there's nothing like 0. So we start with a -1 and -2, right? So if you continue working further, you have that 2 to power 2 is 4 times 1 is 4 plus this is 0 plus 1. And then you open the bracket, you have 1 multiplied by the minus there is the inverse of 2 raised to 1 plus you have 1 multiplied by the inverse of 2 raised to 2. So if you add the numbers at the front of the point here, you have 5 plus these numbers here. If you simplify, you have 1 over 2 plus 1 over 4, right? Okay, so you have the 5 plus the LCM of 2 and 4 there is 4. How many 2's can you see in 4? That's a 2. Multiply by 1, that's a 2. Plus 4 in 4 is 1 times 1 is 1, so you have this. So you have that 5 plus, when you add up this, you have 3 over 4, right? So your answer could be left as 5 whole number 3 over 4. That is when you add this fraction and this together. You can leave your answer in this way, it is 10, or you convert to decimal. 4 times 5 is 20 plus this is 23 over 4. And if you convert 23 over 4 to a decimal, you have it in this form: 4 and 23. 4 goes in 23 5 times. 5 times 4 is 20, subtract you have 3. Drop your point at 0. 4 there is 7 times 4 is 28. Subtract you have 2, add 0, that's 5. 4 times 5 is 20, subtract you have 0. So you have 7, you have 5.75. This number is as well in base 10. Are you seeing the concept now? And for the last question for today, we're asked to convert 111.011 111.011. This number is in base 2. We have to convert it to a number in base 10. So we'll do the same procedure. So we have 1 times 2 plus 1 times 2 plus 1 times 2. That's all for the front. Then plus we have 0 times 2 plus 1 times 2 plus 1 times 2. So we have this. So on top of the front, so we have 0, 1, 2. And for the decimals, we have minus 1, minus 2, minus 3. So 2 to 2 is 4. 4 times 1 is 4 plus 2 to the power 1 is 2 times 1 is 2 plus 2 to the power 0 is 1 times 1 is 1. So we have this at the front plus, since this is times 0, everything here is 0, right? Plus this is going to be 1 multiplied by the inverse of 2 raised to 2 plus 1 multiplied by the inverse of 2 raised to 3. Are you seeing that? So when you add what's at the front, you have 5 plus everything at the front here. This is going to be 1 over 4, right? Because this is 0 is gone. So 1 times 1 is 1. 2 to the power 2 is 4. So I have plus 1 times 1 is 1 over 2 to the power 3 is 8. So you have that 5 multiplied by, if you work on this one here and find the LCM, that's 8. 4 here is 2. Multiplied 1 to give us 2. Plus 8 here is 1. Multiplied 1 to give us 1. So if you continue for that, you have that 5 plus, this is going to be 3 over 8. So you can leave your answer in this way as 5 whole number 3 over 8, or you could have to convert it. 8 times 5 is 40 plus that is 43 over 8, or both of them are correct in base 10. I just changed this one to an improper fraction here, right? So I'm using this to get my answer in decimal. So divide that by 8. 8 goes there 5 times. 8 times 5 is 40, subtract you have 3. Add your point and add 0. 8 there is 3. 8 times 3 is 24. Subtract you have 6. Add point. So when 8 goes in 60, that's 7. And 8 times 7 is 56. When you subtract this, you have 4. Add 0. 8 there is 5. 8 times 5 is 40. And when you subtract, you have 0. So it means our answer is going to be 5.375 in base 10. So any of this is correct. So in case you don't see the right option in decimal, you could see the right option in a fraction too. Right? Thank you for watching, and see you on the next one.